So today we're going to look at what's called complete factoring, in other words, using more than one type of factoring to get a problem done. In some senses, this can be more difficult. The main thing you need to do is make sure, as the slide said, look for any GCF factorings to begin with, because that's where most of these will start with. And then you'll have one of three options thereafter. Either go from a GCF then to a perfect squares, go from a GCF to a guess and check where the A value in front of the trinomial is a 1, and if that A value is only a single factoring of products, then I would use guess and check. You can go to the X method, or if that A term is a set of factors that are more than singular, go to the X method. And we'll take a look at a lot of types of these problems as we go through. So if you take a look at this first problem, you'll notice there's an ax squared term where the a is not a 1. However, there's a greatest common factor. 3 goes into each one of these. So I'll factor out a 3 and be left with x squared minus 6x minus 16. And then this is just a x squared minus bx plus c. So I'm going to look to see what multiplies to 16, adds to 6. So that's 8 and 2. 8's got to be negative, 2's got to be positive, and now it's completely factored. You'll notice in this case I've got some added variables included. There's a 2, it's the GCF, and there's a y in common, so a 2y is my GCF. After factoring the 2y out, I now have x squared plus 11xy plus 30y squared. We've seen this type of factoring before. It's the same type of factoring we did over here. So I have 2y. I need an x and an x. I need a y and a y. And then I need to know what multiplies to 30 and gets me 11. That's 5 and 6. Everything needs to be positive, and that's completely factored. Moving on. There's only 2 terms in these, so there's probably going to be a perfect square or just a GCF to factor. Again, there's a GCF of 12. Factor that out, I have a squared minus 4. You know those are perfect squares. So that's a plus 2 and a minus 2. So in this case, you'll see we have an added variable, but it still really shouldn't matter. We'll still probably get perfect squares as we go along. 18 and 32, I look to see what's in common there. It's probably only a 2, so I factor that out. I'm left with a 9x squared and a 16y squared. 9 and 16 are both perfect squares, so again, I hit 3x, 3x, 4y, 4y. It's a difference of squares, so plus and minus, and I'm done. So in this example, you'll notice there's a 2 as a GCF, and I believe there's an x in common in each one, so let's pull out a 2x, leaving me with 3x squared plus 2x minus 5. Again, this is a guess and check, but in this case it's a little more difficult because I have an a term not equal to 1 here, and it's not a perfect square, so I'll need a 3x and an x. Now this is a little bit easier just because I have a 5 here and there's only one way to get 5, so I could either put my 5 here or put my 5 here. If I put my 5 to the right, I notice that I'll get a 15 when I multiply, and I'm probably not going to get a 2. So I'm going to put that 5 over here and put my 1 right here. If I have a positive 5 and a negative 2, notice what will happen. There's my 3x squared, there's my negative 5, and then my inner multiplication is a 5x. My outer multiplication is a negative 3x, which is a 2x. So this is completely factored. In this example, we'll have another GCF. In this case, it looks to be a 3 and then an x cubed. 3 times 12 gives me 36, and I have an x squared left. 3 times 5 is 15, have an x left, and 3 times 3 is 9. No x's left. Now, we're going to need to take and factor this to completely factor. And because the 12 has multiple factors, I'm going to use the x method. So I'll create my x, look for my a times c term here, which is a negative 36, plus or minus b term is a negative 5, and I need two terms that multiply to 36 and get me 5. 9 and 4 is going to do the trick with the 9 being negative. So again, I will say, all right, my first term is going to be 12x squared. My middle terms are the negative 9 and the 4. And then I end with a negative 3. So I take and group. You'll notice here I have an x and a 3 in common, leaving me with a 4x minus 3, plus that 4x minus 3. Again, GCF, pull out the 4x minus 3, and I have a 3x, and remember, there's that invisible 1 sitting out in front here. So we have a 3x plus 1. And then if I add my 3x squared, or 3x cubed, there's my complete factoring. So this may not look like a complete factoring problem, but here's the deal. I do not like factoring with a leading coefficient of a negative, and I say that's a leading coefficient because I would write this with my x squared term first, so that's 3x, negative 3x squared plus 5x plus 2, and I don't like a negative as my leading coefficient, so what I'll typically do is say, well, there's a negative in common in all these. If I factor out a negative, then negative 1 times 3 is negative 3x squared. Negative 1 times negative 5 is a positive 5x, and negative 1 times negative 2 is a positive 2x. And now I have a guess and check in here. Again, there's only one way to get 3, so I'll put my 3x and my x. And there's only one way to get 2, and I'm going to need a 5, so I'm going to put my 2 over here and my 1 here. Notice the 3 times the 2 is a 6, and the 1 times the x is a 1. 6 and 1 give me 5. This is going to do it. And here is my negative 6 and my positive 5. Problem done. So again, try not to factor with a negative leading coefficient, and always arrange your terms in descending powers of x. In this problem, again, we have our leading term, 4x squared, as a negative. I don't want to factor out that negative, leaving me with 4x squared plus 4x minus 15. Since 4 has multiple products, I'll go to my x method. AC here, plus or minus b here. A times c, that's 4 times negative 15 or negative 60. And I need a 4 out of that. Let's see, 60, 60, 60. I can go 6 and 10, right? 10 and 6. And I need a positive 4, so the 10 is positive, the 6 is negative. Again, we're looking at this trinomial to factor, so I have my first term, which is 4x squared. I use my 10x minus 6x minus 15. This has a 2 and an x in a common, leaving me with a 2x plus 5. Pull the negative out, and a 3. And we have a 2x plus 5. GCF once again, 2x plus 5. and the 2x minus 3 is left. And don't forget that negative out in front. And there is my complete factoring. In this next problem, you'll see there's 4 terms, so this is likely going to have a grouping involved in it. But before that, I look and there's no GCF with the integer values, but there is a GCF with the variables. There's an x squared in common in all the terms. I have a 4x to the third plus 6x squared plus 6x plus 9. And then I'm going to try to group. I'll group these two here and say that's x squared. Put this in a bracket. In this, I have common terms of 2 and x squared, leaving me with a 2 and an x, and then plus a 3. In this term, I have a 3 in common, which leaves me with 2x plus 3. And there's my group factoring, leaving me with another common term of 2x plus 3. So I leave my x squared outside. I pull out a 2x plus 3 because that's my common term. And what's left is the 2x squared plus 3. So I could rewrite that if I want as x squared times the quantity of 2x plus 3 times the quantity of 2x squared plus 3. Again, here's another likely group factoring. I have no variables in common this time, so I'll just start by grouping these two terms and hope this works out. Got a 9 in common and an x squared, leaving me with a 3x minus 2. And then I want a 3x minus 2, a positive 3x, so I'm going to pull out a negative 4 right here, leaving me with a 3x minus 2. So you'll notice the common term now is the 3x minus 2. I'll factor that out. And then I have 9x squared minus 4 remaining. But now we'll notice that the 9 and the 4 are perfect squares. So here's my 3x minus 2. And then square root of 9 is 3x and 3x. And then square root of 4 is 2 and 2. And I need a negative, so I have to have a plus and minus. So you can leave it like this, or you can write it as 3x minus 2. Since there's 2 of them, I can say that's squared, and a 3x plus 2. And then finally, we can solve for x with common factoring as well. This is going to bring about a little different take on the problem, though. We want to make our highest term our positive, or our highest power our positive term. So I'm going to take and bring the 6x cubed to the other side by adding. And since I'm going to be probably factoring, I'm going to need a side set equal to 0. So I'll subtract 10x as well. And then I will arrange this in descending powers of x. So I have 6x cubed minus 4x squared minus 10x equals 0. I notice there's a GCF of 2x, leaving me with a 3x squared minus 2x minus 5 equals 0. This is going to take some guessing checking, but I have a 3x, so that's good. There's only one thing that gets me 3, and there's only one thing that gets me 5 as well. I think we've seen an example like this before. I need a 2 when on my inner products, so I'll take and put my 5 here, my 1 here, Notice this is a 5 and a 3, which gets me a 2. I need the 2 to be negative, so my 5 has to be negative, leaving my 1 as the positive. But this is all equal to 0, and I'm trying to solve these. Now, we have had a zero product principle, which said A times B equals 0, so A equals 0 or B equals 0. But in this case, we have three terms. So we have A times B times C equaling 0. So A could equal 0, or B equals 0, or C equals 0. So in this case, I'll set all these equal to 0. My A term is 2x. Divide by 2 to both sides. So x could equal 0. 3x minus 5 equals 0. Add 5. 3x equals 5. Divide by 3. X equals 3/5. And x minus 1, or plus 1, sorry, equals 0. Subtract 1. And x equals 1. So I have three answers. 1, 3/5, and 0. And that'll do it.